Hello everyone, this is Rashika Janjarla. I am an educator in Unacademy. You can follow me on Unacademy Learning app where you can find math course as well. In this lecture, you are going to see the design analysis of the extra full length leaves of multi-leaf springs. And please rate, review and share the video and also subscribe to Unacademy YouTube channel.
Welcome again to multi-leaf springs part 2. The group of graduated length leaves and the master leaf can be treated as triangle plates. So the design analysis of the triangle plate resembles the design analysis of the graduated length portion of the multi-leaf springs, right? So in the last lecture we have followed the same process and we have found the bending stress values for the triangle plate shown in this figure. So see here, we have the triangle plate which has a width at the support given by in G into B and it has a thickness of T. So now in this section we are going to find the deflections. So it can be proved that the deflection at the load point of the triangle plate is given by delta G equals to PG L cube by 2E I maximum. So on substituting the value of I maximum and the value of PG, we have got PG into L cube by 2E into 1 by 12 NGB T cube. So on simplifying this equation, we can get the value of the deflections for the graduated length leaf portion of the multi-leaf springs given by delta G equals to 6 PG L cube by ENG BT cube. So this is the formula for the deflections of the graduated length portion of the multi-leaf springs, which includes the master leaf of the multi-leaf spring also. So design analysis of extra full length leaves group of the spring. So in the previous sections we have discussed about the graduated length portion of the multi-leaf springs including the master leaf, right? Now we are going to see the extra full length leaves of the multi-leaf springs which are used to support the transverse shear load, right? So now we are going to discuss about the design analysis. The extra full length leaves can be treated as a rectangle plate of thickness T and uniform width NFP as shown in the figure. So these extra full length leaves can be treated as the rectangle plates shown in this figure. So these are the rectangle plates of length L and thickness T, and they are arranged as shown in the figure. They have the uniform width given by NF into B, where NF is the number of the extra full length leaves. Okay, so the distance between these two is B here, and their width is B by 2, and here also B by 2. Okay, so the bending stress at the support is given by sigma BF equals to MB by I, and on substituting the value of MB, which is the bending moment acting at the support, which will be the product of the length and the length between the point of interest and also the line of action of the force and the magnitude of the force, right? That is PF into L. And for Y we have T by 2, where T is the thickness of the extra full length leaves, and we have the moment of inertia formula 1 by 12 into NFB into T cube. So on simplifying this equation, we can find the value of bending stress at the extra full length leaves of the multi-leaf spring given by sigma B into F equals to 6 PF into L by NF BT square. So these assumptions are treating the parts of the multi-leaf spring as the rectangulars here and the triangle plate here are useful for the simplification of the design analysis. Okay, so they are approximately same. So we have found the bending stress with this relation. So now we are going to see the deflections of the extra full length leaves portion of the multi-leaf spring. So the deflection at the load point is given by PF into L cube by 3EI. Load point is this point. At this point we have the deflection given by delta F, that is PF into L cube by 3EI, and on substituting the value of the moment of inertia we have delta F equals to PF into L cube by 3 into 1 by 12 and FB into T cube. So on simplifying this equation for the value of deflection, we can get delta F equals to 4 PF into L cube by ENF BT cube. So the delta F value is obtained for the beams under bending loading. So this deflection is this relation is obtained in the discussion about the beams under bending. Okay, so it is good if you go through the lecture where I have presented the deflections of the beams under bending. So this relation obtained from there, and here we are used the value of P and the value of moment of inertia of the cross section of the extra full length leaves of the multi-leaf spring. So on using those values, we have got the value of the deflection with this value, delta F given by 4pf into L cube by ENF BT cube. So the value of the loads acting on each portion of the spring can be obtained with the help of this discussion. Okay, since the deflection of full length leaves is equals to the deflection of the graduated length leaves. So we have found the deflection of the graduated length of the leaves and also the full length leaves, and their value should be equals, because these portions of the multi-leaf springs are included in the multi-leaf spring, right? Their deflection should be same, and their value is the 6 pgl cube by ENG BT cube for the graduated length of the leaves, and for the full length, extra full length leaves, we have 4pf into L cube by ENF BT cube, right? This one. So on making these two values equal, we can get the value or the relation between PG and PF, where PG is the portion of the load taken by the graduated length leaves and PF is the portion of the load taken by the extra full length leaves of the multi-leaf spring. So the relation is PG by PF equals to 2NG by 3NF. So with this relation and also with this relation, PG plus PF equals to P. So these two forces are the portions of the P, right? The external load. That's why we have PG plus PF equals to P. Since the multi-leaf spring is under equilibrium. So on solving both the equation, this one and this one, we can get the value of the individual forces acting on each portion of the multi-leaf spring given by PF equals to 3NFP by 3NF plus 2NG, and we also have the formula for the force acting on the graduated length leaves of the multi-leaf spring given by PG equals to 2NGP by 3NF plus 2NG. So these values should be used for the calculation of the stresses, the bending stresses in the leaf portions of the multi-leaf springs. Okay, so these values PF and PG values should be substituted in the values of the stresses and also the deflections. Okay, so these two values are very important in the calculation of the deflections and the bending stresses in the leaves of the multi-leaf spring. Thank you.